Good morning, children. How are you all? I hope you are fine. Yes. In the last two sections, we have discussed about the first chapter, number system, and we have completed the first exercise in number system. Yes. What are the things we have discussed in the first exercise about the rational number and irrational number? We are clear about what is rational and what is irrational, isn't it? We have solved the first exercise clearly. So now we are clear about what is rational number and what is irrational number. Today in this section we are going to solve exercise 1.5. The next exercise in our chapter 1.5. Here also we are going to discuss about the rational and irrational only. Okay, but addition, subtraction are identifying the irrational numbers we are going to do here. Okay, children. Yes, think of once. What is the rational number? Is a number in the form of p by q. P and q are integers and q not equal to 0. This any number satisfies this condition that is called as a rational number. What is the irrational number, children? A number that cannot be expressed in the form of p by q is called as the irrational number. And we have discussed the main thing about the rational and irrational number. The decimal expansion of the rational number. Okay, for rational number, the decimal expansion will be terminating. Either it is terminating. If not terminating, is repeating. Terminating, non-terminating and repeating. This comes under the rational number category. What about the irrational number? Non-terminating, non-repeating. Non-terminating, non-repeating means it comes under the irrational number. Also, I gave it to the square root of all the prime numbers, isn't it? The prime numbers, the square root of the prime numbers is always irrational number. And other point about the rational number, all the natural number, whole number and integers, all things belongs to the rational number. Rational and irrational is the set of all belongs to the number of real numbers. This is what we have discussed in the first exercise, also in the intro part, isn't it? Today we are going to solve exercise 1.5. In the first problem we are going to solve now. See the question. Classify the following numbers as rational or irrational. Here they gave some question, isn't it? They gave some questions in the form of addition, subtraction, also in division. We have to check or classify the number whether it is rational or irrational. Okay. So if it is in decimal, we have a point how to find it is rational or irrational. Now here we have to conclude using how. See the first subdivision. What is the first subdivision question here? 2 minus root 5. 2 minus root 5. What about the 2, children? What is the nature of 2? It belongs to rational or irrational number? Yes, 2 is a rational number. What about root 5? Square root of 5. 5 is a prime number. And we are having a square root here, square root of 5. So what is square root of 5? It is a irrational number. So see here, we are subtracting irrational number from rational number. We are subtracting an irrational number from rational number. So the result what we get, what we will be getting is a irrational number. Surely the result will be an irrational number. So what we are doing here? Here we are subtracting irrational number from rational number. The result of this will be an irrational number only. Okay. So the given here is an irrational number. It's an irrational number. Yes. So using this one example, you can conclude that whenever you are subtracting from one rational and the other irrational number, rational from irrational or irrational from rational, surely the result will be an irrational number only. Yes. Come for the second subdivision. See the second subdivision. What's the question? 3 plus square root of 23 is included here minus square root of 23. Yes. See whether it is able to solve. Here we have the solving option. Okay. So that we can't subtract. So I told that the answer will be an irrational number. So we concluded it as an irrational number. Here I can use some rules to solve. Just first we simplify and see whether the result is rational or irrational. Let us simplify now. What is the question we are having? 3 plus square root of belongs to the rational number only. So 3 can be also written in the form of p by q. So surely 3 is a rational number. So here the given expression is a rational number. So it is a rational number. Yes. Now the third subdivision, 1 divided by root 2. So here we are having a numerator as well as the denominator. Okay. So you may tell, ma'am, it is in the form of p by q only now directly. One numerator is there, denominator is there. Why can't we say it is as a rational number? Be clear with the definition of the rational number. P and q are integers. P and q are integers. The numerator and denominator will be some integers. But here the denominator what we are having? Square root of 2. Square root of 2 is not an integer, isn't it? So here in the numerator we are having number 1. 1 is a rational number. Yes. Square root of 2. 2 is a prime number. Square root of 2. What is the word square root of 2? I mean, what is that? Comes under the irrational number. We are dividing a rational number by irrational number. Whenever you are dividing a rational number by irrational number, the result is also an irrational number. So it is an irrational number. It is an irrational number. So from these 3 examples given, whenever you are subtracting a rational from irrational or irrational from rational, surely the result will be an irrational number. Likewise in division also, if you are dividing a rational by irrational or irrational by rational, surely the result also an irrational number. If any question is given in the form of simplify, you have to simplify and check whether the answer is rational or irrational number. Okay children, so we'll solve the second problem now. Now let us solve the second problem. Simplify each of the following. Here they gave some expressions. We have to simplify this expression. Okay, this expression is the combination of rational and irrational number. We have to simplify this expression using identities and we have to tell the answer. Yes? Now, what is the first question? 3 plus root 3 into 2 plus root 2. What we have to do here? We have to multiply. Okay, 3 plus root 3 into 2 plus root 2. This indicates we have to multiply and simplify this. Yes, let us multiply now. So see the first problem. We are having 3 plus root 3 into 2 plus root 2. How we are going to use this? How we are going to multiply this? Using this condition, if you are having a plus b into b plus c. If you want to multiply like this, the terms, how we have to multiply this? A should be multiplied with the second next to 2 terms. Okay, and b should be multiplied with the 2 terms. So how we can write this? A into b plus c. That means a should be multiplied with both b and c. Plus, in middle we having plus b into b plus c. b into b plus c. See, a should be multiplied with the second term plus of b should be multiplied with the second term. Okay, so after this we have to multiply and remove the bracket. This rule only we are going to use here and we are going to multiply and get the product of this problem. So see, so in place of a, b, c, we are having numbers 3 plus root 3, 2 plus root 2. So how to multiply this? First take the number 3. 3 should be multiplied with the second term. What it is? 2 plus root 2. Yes? In middle we are having plus. So take the symbol plus. Instead of plus, if it is minus, we have to take minus. So next term is root 3. Root 3 into the multiplication of second term. So 2 plus root 2. Yes? Now we have multiplied. Now we have to remove the bracket and multiply each and every term. So 3 2s are 6. Just I am taking 3 inside the bracket. So first term should be multiplied with 3. Also the second term should be multiplied with 3. So 3 2s are 6 plus 3 into root 2. That is 3 root 2. 3 into root 2 is 3 root 2. X. Now the next term. Root 3 should be multiplied within this bracket. So 2 into root 3 is 2 root 3. 2 into root 3 is 2 root 3. 3s are 6. Yes. Now, anything to add? Any common terms are there? No. See, 6 is the rational number. Here we are having the combination of rational and irrational. Again, we are having the combination of rational and irrational and the square root of 6. And 6 is not a perfect square number. So, we can't add or subtract anything. Just conclude the answer as it is. So, in order, if I conclude this 6 plus 2 root 3, just I am concluding in the order. That's it. 3 root 2 plus root 6. So, if I expand this, if I multiply and got the simplification as 6 plus 2 root 3 plus 3 root 2 plus root 6. Here we are not having any common number. We are not any two rational or we are not having the same values to add here. So, this is the final answer. You can use this. Okay, whenever you are multiplying the two things in product. Okay, you have to multiply first value with the next product, second value with the next product and get the answer. Also keep this rule in mind. Whenever you are multiplying root a into root b, which is equal to square root of a into b. So we used this and we have concluded the answer 6 plus 2 root 3 plus 3 root 2 plus root 6 is. Now come to the second subdivision. 3 plus root 3 into 3 minus root 3. Now the second subdivision, 3 plus root 3 into 3 minus root 3. Here also we have to multiply, isn't it? The first term should be multiplied with the second term. See, any clue here you are finding in the second problem? 3 plus root 3, 3 minus root 3. Here the first term is 3, in the second also the first term is 3. Here it is root 3, also in the second term also it is root 3. Indirectly the question indicates the formula in algebra identity. What it is? What identity you remember using this? A minus b into or a plus b into a minus b. A plus b into a minus b is equal to what is the identity? A square minus b square. A square minus b square. In first subdivision we can't use the identity, just we multiplied and got the answer. Here by seeing the question we got an idea what it is. We can use the algebraic identity directly because the given question is in the form of a plus b into a minus b, which is equal to a square minus b square. So here in the place of a, what we are having here? 3, and in the place of b we are having root 3. Just using the identity we are going to solve. Okay, so 3 plus root 3 into 3 minus root 3. If you use this identity, a square minus b square, that is a here is 3 square and b square is root 3 the whole square is 9. 3 3s are 3 square plus 3 square, that indicates 3 into 3. The answer is 9. So it is 9. What about root 3 the whole square? Root 3 the whole square. Here square and square root we get cancelled because square root is indirectly. Square root value is indirectly 1 by 2. Okay, so we can expand this also. How much? 3 power 1 by 2 whole power 2. So 2 and 2 will get cancelled. The answer is equal to 3. So minus 3. That way you can, whenever you are having square and square root, they are reciprocal functions. So that way you can cancel them. So square and square root can cancel directly and we got the answer as 3. So what is 9 minus 3? The value is 6. So here we simplify that back. Given expression 3 plus root 3 into 3 minus root 3 using an algebraic identity a plus b into a minus b, which is equal to a square minus b square. If I simplify, we got the final answer as a rational number, that is 6. Yes. I hope you are clear with this now. Let us solve the third subdivision. Root 5 plus root 2 the whole square. Actually here they have given in the form of the function of square. A plus b whole square. Now you remember the identity by seeing the question itself we have to compare with the algebraic identity what we can use to solve. See the question, root 5 plus root 2 the whole square. What is the way to solve this or expand this? Only using an algebraic identity. What is the formula? A plus b the whole square. We can expand this using the formula a plus b the whole square. What is the expansion of this? A plus b the whole square. A square plus b square plus 2ab. A square plus b square plus 2ab. What is a here? A B in the given question we can take it as root 2. A we can take it as root 5 and B as root 2. So using this identity we are going to expand the given question and we are going to find the answer. Yes, let us solve it. Root 5 plus root 2 the whole square. So what is the expansion? A square, that is A is root 5. So root 5 the whole square plus B square. B is root 2. So root 2 the whole square plus 2AB. So plus 2 into root 5 into root 2. Root 5 into root 2. So you can put the multiplication symbol or you can use the bracket. Okay, fine. Now root 5 the whole square. Now only I told it. What I explained it. Square and square root are reciprocal functions. So we can directly cancel them. So what is the value we are getting? 5. Only 5. Again in the second term, root 2 the whole square. Here also square and square root will get cancelled. So the answer is plus 2. What about the third term? We are having a rational number 2, so no problem. Root 5 into root 2. Have you remembered that? Any root number, a into root b, we can write it as root ab. We can write it as root ab. So using that rule, what is the answer? What is the answer you are computing? Plus 2 root 10, because 5 roots are 10. So plus 2 root 10. What will be the final answer, children? 5 plus 2, we got the value as 7 plus 2 root 10. We are having one rational and another irrational number. Rational and irrational number cannot be added. So this is your final answer. So we got the simplification of the third subdivision. Root 5 plus root 2 the whole square as 7 plus 2 root 10. Okay. Whenever you are having the expression to simplify, first if it is a normal multiplication, multiply and get the answer. I'll see the question. If any clue in the question for using algebraic identity is, choose the appropriate algebraic identity and expand it easily and get the answer. Okay, children. So let us solve the third problem now. See the third problem, children. Here the question is given. Okay. See read the question carefully. Then only we can know what we have to solve or what we have to explain in this question. See, recall pi is defined as the ratio of the circumference, say C, of a circle to its diameter, say D. That is, pi is equal to C by D. What's this here? Okay, there is a circle and whose circumference is taken as C and whose diameter is taken as D. Pi is given as the ratio to the circumference and diameter. That one they take that is C by D. So pi is equal to C by D. That is the first point. This seems to contradict the fact that pi is irrational. We know that clearly pi is an irrational number. Isn't it? But the given form contradicts that. Contradicts that means opposite. And it is it is not true, like the contradiction will come. So it contradicts the fact that pi is irrational. How you will resolve this contradiction? What is the solution for this contradiction? And how you will resolve it? For what values this contradiction will be resolved? Because surely we know that without doubt pi is an irrational number. But in this question they gave pi as the ratio of circumference and the diameter. They gave in the form of p by q. How they expressed pi in the form of p by q. Any number in the form of p by q is called as a rational number. So here the given indicates that pi is a rational number. Surely there is a contradiction, no? Because pi is an irrational number. That is given here. It contradicts the fact that pi is irrational. How do we resolve this? How do we resolve this contradiction? No, pi is irrational only. How we can say for this expression? Okay. So for the first problem we solve now. If any rational number added with irrational, the answer is irrational. Rational number subtracted with irrational, it is an irrational. Likewise, any rational number divided by irrational, it is irrational. Also, if you divide two irrational number, again the answer is also irrational number. So using this concept only, we are going to explain this. Okay. So C pi is equal to C by D. Actually Actually, they have given in the form of p by q. So here that indicates it's a rational number. So there is a contradiction. How to resolve it? How we have to resolve it? We are writing there is no contradiction. How? How we can resolve the contradiction is if c is a rational number. Okay, if c is a rational number. For example, I am taking c is a rational number and p is an irrational number. C is rational and d is irrational. So any rational divided by irrational, what will be the result? Irrational number. So one point I gave, we can give as if c is rational and d is irrational. The other point may be c irrational, the numerator point, and d is rational. If the numerator is irrational and the denominator is rational, then also the answer comes under irrational condition. So we can say either C or D. So see the solution here. If either there is no contradiction, in which case if either C or D or both, if irrational number divided by irrational number, again the answer is also irrational number. If I am dividing two irrational numbers, the answer is also irrational number. So we can take the third choice as C and D both irrational number. So if C is irrational, then also pi is going to end as irrational number. If D is irrational, then also the value of pi is going to irrational. If both C and D both are irrational also, pi goes under the irrational number only. So the way how to solve this contradiction is we can get the values of C. See here, if either C or D or both C and D are irrational, then pi is equal to C by D is irrational. Okay, we are not having any particular value here. In general value we are explaining C and D are unknown value. But in which case they become as irrational number? Either in a numerator is C, denominator is D. Either numerator or denominator, that one we gave us C or D, or both, that one we gave us C and D. In these cases, surely pi is a irrational number. So using this, we can resolve this contradiction. Okay, children. The next problem in the exercise, rationalize the denominators. What does it mean by rationalize the denominator? See here, I took two problems. The two denominators are irrational number. We have to rationalize them, make us rational number the denominator. Okay, only the denominator, no need to bother about the numerator. Numerator is rational or irrational, no problem. Just you have to rationalize the denominator. Okay, so see, we are having 1 by root 7. 7 is a prime number. Square root of prime number is an irrational number. So surely here the denominator is an irrational number. We have to rationalize that, isn't it? How? So see, maximum the whatever 1 by root 7. To rationalize this, whatever in the denominator, what will be the value in the denominator? Okay, we have to multiply and divide by the same value. Because if we remove the square root, the number 7 is a rational number. So what is the simple way to remove the square root there? Just multiplying and dividing by root 7. Okay, so I am going to multiply here by root 7, also divide by root 7. Okay, now because whenever you are multiplying and dividing, it will not affect the original question. So only we are taking multiplying and divide both here. Now we will be the step. What we have to do? We have to multiply numerator with numerator, denominator with denominator. 1 into root 7. What is that answer? Root 7. And here root 7 into root 7. Okay, so you may write x into x. You know that x into x is equal to x square. Like that I am going to represent here. So root 7 the whole square. Okay, because here we are multiplying like x into x. How do you multiply the same thing? Root 7 into root 7 is root 7 the whole square. Already explained in the previous problem. Whenever you are finding square root and square root, they are reciprocal functions. So directly what they will happen, they will get cancelled. Okay, yes. I will explain how, because square root of 7. Square root of 7 we can write square root will get cancelled. The remaining is only 7. Now see the denominator. What is the denominator here? It is 7. Whether 7 is a rational number or irrational number? Yes, it is a rational number. So we rationalize the denominator of 1 by 7 here and we got the answer as square root of 7 by 7. Okay. So whenever you are having a square number here, to rationalize that square number denominator square, just multiply and divide by the same number. Multiply and divide by the same number. So that you will be having a square function. So that square root will get cancelled. Automatically the denominator will be rationalized here. Okay. So the second problem. 1 by root 5 plus root 2. Okay. Here we are having two numbers in addition operation. So what we have to do is, see the question, 1 by root 5 plus root 2. So see, I want to make square, then what is the square root here? Okay, have you remember the identity? What is the identity? A square minus B square, because here we are having the plus operation. Something I have to multiply and divide. I have to choose what? So see the denominator whether it is plus or minus. Use this identity to find the other number. A square minus B square is equal to A plus B into A minus B. Okay, if A plus B is given, if you multiply by A minus B, A plus B is given, if you multiply by A minus B, I can use this identity. If A minus B is given, multiply by A plus B, then also we can use A square minus B square. Either the denominator will be in the operation plus or minus. If plus is there, multiply with the minus. Minus is there, multiply with plus. So that I can use the identity A square minus B square. Okay, to rationalizing the denominator will be very easy. Yes. Now, so see here we are having plus. So what we have to do? I want to get A square minus B square plus. Here A plus B is there. I have to multiply with A minus B. Instead of A, B, here we are having root 5 and root 2. So multiply and divide by root 5 minus root 2 by root 5 minus root 2. Are you clear? So then only, because if you want to rationalize this, I have to remove the square root, because square root of 5 is a irrational, square root of 2 is a irrational. If we add two irrational number, again the answer is also an irrational number only. So what is the best thing is, if I remove the square root of this, okay, numbers in the denominator, it will become the rationalized denominator. So how to remove this? I am using the identity A plus B, A minus B is equal to A plus B into A minus B is equal to A square minus B square. Either in the denominator if A plus B is there, multiply by A minus B. If A minus B is present in the denominator, just multiply by A plus B. So then you can use this identity and rationalize the denominator. Okay, yeah. Here A plus B is there, so I multiply by A minus B and A minus B. Multiply and divide by. Now, what is the step? I have to multiply the numerator. What is the numerator here? 1 into root 5 minus root 2. That is root 5 minus root 2. Because 1 into any number is the same number only answer. So 1 into root 5 minus root 2 is root 5 minus root 2. By. What about the denominator? How to multiply? Okay, already we fixed it. We are going to use identity. So use identity. This is A plus B, A minus B. So A plus B into A minus B is equal to A square minus B square. So what is A square here? Root 5 the whole square. And what is B square? Minus root 2 the whole square. Minus the root 2 the whole square. A square minus B square. Now give the numerator root 5 minus root 2. Again, I hope now you are very clear about how to simplify this. Square and square root will get cancelled. Here also square and square root will get cancelled. So what is the value? We are having only 5 minus 2. What is the value? 5 minus 2. Good. Now, root 5 minus root 2 by 5 minus 2. What is the answer? 3. 5 minus 2 is 3. So see the denominator. There is a rational denominator, but finally we got it as a number 3. Number 3 is a rational number, so we rationalize the denominator here. Okay. So whenever you are having a single square root operation in the denominator as a rational number, just multiply and divide by the same number. Automatically the denominator will be rationalized. Next type of question will be like this. Maybe the denominator has the operation plus or minus. If A plus B means just multiply by A Some example based on addition and subtraction of rational numbers. Okay, see here. Add 2 plus 5 root 3 and root 3 minus 3 root 3. Okay, in algebra we add the terms. Okay, how we will add the terms? Algebra contains variables, whatever it is, arithmetic numbers and mathematical operation. How we will add or subtract the algebraic terms? Only the like terms are added and the like terms are subtracted. As like here, if we are having the square roots, okay, see we have to add this 2. So 2 root 2 plus 5 root 3 plus we have to add simultaneously plus root 2 minus 3 root 3. Here root 2 and root 3 cannot be added here, but root 2 will be added with the root 2 value. How we use in the algebra? Like terms are added and like terms are subtracted. Same thing use here. Okay, the value inside the root, if they are same, we can add it. If the value inside the root is different, we can't add it. See, root 2, root 3. This term, these two terms cannot be added. They are unlike terms. Here, root 2, root 2. Okay, so after combining this test, I am rearranging the like values. So 2 root 2 plus we are having 1 root 2. Root 2 means it will be taken as 1 root 2. So root 2. The other thing is 5 root 3 minus 3 root 3. Okay, so whenever you are having the irrational numbers, just add the numbers according to the like terms. Okay, now just we have to add the coefficient. For example, in algebra, how we will use, how we remember 4x plus 5x, 4x plus 5x. How we will add? We will take 4 plus 5, the coefficients and x, that is 9x. The same rules only here. Just we have to add the coefficient. Okay, it will not be added. Root 2 and root 2 cannot be added inside the root. Just we have to add the coefficient. So what is the coefficient here? 2, here 1. So 2 plus 1 root 2. So 2 plus 1 root 2. Likewise, here root 3 root 3. So surely we can add or subtract that. Okay, so what we have to do? We have to just subtract the coefficients. So what is the coefficient here? 5 minus 3. 5 minus 3 and root 3. So what is the answer? 2 plus 1 is 3 root 2. 5 minus 3 is plus 2 root 3. Here root 2 and root 3 values cannot be added. Okay, so whenever you are adding or subtracting the rational terms, keep in mind algebra is very useful here. Okay, so how we are adding and subtracting the algebraic terms? Same only. Like terms can be added and like terms can be subtracted. Likewise, whenever the values inside the square roots are equal, the terms can be added. Okay, only the coefficients can be added. Likewise, the coefficients can be subtracted. Okay, so using this problem, so you have to learn how the rational numbers can be added or subtracted. The next example, children, here multiplying two rational numbers. 6 into root 5. Irrational number. 6 into root 5. 6 is rational. Root 5 is irrational. So 6 into root 5 is irrational number. Likewise, 2 into root 5 is irrational number. How to multiply the two irrational numbers? Okay, here we are going to multiply. So 6 root 5 into 2 root 5. How to multiply? Just multiply the coefficient as well as the root values also. Okay, now remember, we already saw the problems. Root a into root b. Root a into root b is equal to, we can write as root of a into b. Like root of ab. Likewise, if I multiply the root a into root k, the same values I can write it as root a the whole square. Root a the whole square. So, whenever you are having same values or different values, while multiplying, the values inside the roots also multiply. Okay? Now, for this example, already we saw this. Okay, already we saw this. We used in the middle of the problems. Right? Now, for example, if I take the question 6 root 5 into 2 root 5. How to multiply this? Just multiply the quotient which is 12. 6 into 2 is 12. And you have to multiply, you don't know, as you have to multiply the values inside the root also while multiplying. So if I multiply root 5 into root 5, they are same value. If 2, 3 months, I can write it root 2. Root 2 into root 3 months, you can write it as root 6. Okay, but the same value here, so what we 5. What is 12 into 5? It is 16. Okay, while adding or subtracting, how you will keep the variable as it is likewise, the roots will be maintained like that. Okay, if I am adding 3 root 2 plus 5 root 2, we have to add only the coefficients. 5 plus 3 is 8 root 2. We have to give the values like that. Okay, for addition or subtraction, you have to add or subtract only the coefficient for the like terms. But in multiplication, all the values are multiplied. Okay, coefficient, also the value inside the root also multiplied. Okay, root a into root b can be written as root square root of a into b. Same number means I have to put square. Okay, so use this problem for multiplication. Take this example for using the other problems to multiply. So with this we have completed our exercise 1.5 exercise children. Okay, today we have learned about how to rationalize the denominator. Okay, if the denominator is irrational, how to rationalize it, and how to add or subtract or multiply the irrational numbers, and how to identify the given expression as rational or irrational. Okay, so based on the exercise what we have solved today, you will be getting a homework PDF also. Okay, you have to complete your homework based on the same manner and submit it to the group. Okay, children. Children, we have seen in our class today about rationalizing the denominator, isn't it? Here is an activity you are having based on rationalizing the denominator. Okay, it is a fun activity. See, first I will explain the activity, how we are going to complete this. What do you call friends who love math? That is a fun question here. What do you call friends who love math? If your friends love the mathematics very much, what is the name you can call using maths? That's the question here. See, that for answer I gave here. Okay, how many characters are there? Means 8. So it is a 8 letter word. It is a 8 letter word. For all the 8, I gave here a question. Okay, from 1 to 8, I gave here the question, and here the answer choices. For all the alphabets, I gave some answers. Okay, so you have to, how we are going to finish this means, you have to find the answer for all these 8 questions. It is hidden here in this alphabet only. Okay, A to Z. The answer is hidden here only. You are going to find the answer for these 8 questions. Okay, so to solve how it is, I will solve 1 or 2 example for you. See here, for example, if I take the second question, is okay. If I take the second question, what is the question here? 1 by root 7. 1 by root 7. How we have to do this? You have to rationalize and find the answer. What we are doing in the exercise, the same thing. You have to rationalize and find the answer. 1 by root 7. For example, see here. I solved already 1 by root 7. If I am rationalizing, the answer is root 7 by 7. If you find the rationalized form, the answer is root 7 by 7. In this alphabet, you have to search for the answer. Where is root 7 by 7? Identify the answer. Root 7 by 7 is here in the alphabet L. Root 7 by 7 is in the alphabet L. Where it is finds? It is in L. So, the answer for the second question is in the alphabet L. Okay, no need to write the answer. Just identify the alphabet and fill in that column. Where we have to fill? The second question is here. Okay, see, on the number basis, on this order you have to fill the answer. So I chose the second question and I got the answer root 7 by 7. It is in the alphabet L. So in the second place you have to fill the letter L. Okay, choose any other. Shall we choose the question number 6? Okay, randomly I am choosing it. If you take 6, 7 by root 5 minus root 2. 7 by 5 minus root 2. What you have to do is you have to rationalize the denominator. See here, 6th question. If I rationalize the denominator using the process, the answer is 7 into 5 plus root 2 by 23. 7 into 5 plus root 2 by 23. Okay, yes, you have to find where this answer is in the A to Z alphabets. 7 into 5 plus root 2 plus root 3. See where it is here. 7 into 5 plus root 2 by 23. In which alphabet it lies? It is in S. So, for 6th question, the answer lies in the alphabet S. Where is the answer? See, 6 we have to Here. The place for 6 is here. So we have to fill the alphabet. Yes. Okay, no need to fill the answer. Just fill the alphabet. Yes. So in this puzzle, okay, out of this 8 questions, I worked out for 2 questions and I gave you the clue how to find the answer. You have to solve and identify the alphabet and fix in the appropriate place so that you will find the answer for this question. Okay, what do you call friends who love math? Okay, find the fun answer and enjoy yourself. Try this activity in your home, children. Also complete your assignment PDF as well as the activity also and send through the group. I hope you enjoyed this activity. Try yourself and find the answer what you are getting. See the answer and enjoy. Okay children, thank you.